Recording in.
Hello everyone. Welcome to this month's Full Stack Community. As a reminder, we meet about every 8 weeks or so. Have ideally a couple of talks on topics of interest to software developers in general, and then we go and meet in the diner afterwards for refreshments, paid for by IDS. So do come and stay after the talk. So we've got two talks today, both on UI, and so we've got building UI from Jess and testing UI or majoring on testing UI from Steve and Seema. Sina, sorry. So without further ado, Jess.
I'm just going to push this down a bit further. These aren't made for short people. Thank you, Andrew, for introducing me. As the title suggests, this presentation is primarily aimed at those who generally develop back-end work, who don't focus so much on front-end work. So I'm sorry if you're a seasoned pro, this may cover old ground, but as the meme in the corner suggests, I promise to entertain you in the form of memes throughout. As a warning, this is designed to be a whistle-stop tour of front-end development. There are a lot of topics here. I don't have very long and I can't go into detail on each one. So if you want more information, please feel free to come to me afterwards and yeah, ask away. So there's quite a lot, like I say, to cover. Initially, we're going to be covering structure and aesthetics within HTML and CSS. Then we're going to be looking at how to simplify the process of styling your web pages using UI frameworks, and I've chosen Bootstrap as an example for that. And finally, we're going to be looking at interacting with the user interfaces using JavaScript and why you should all be using React.js or another UI library for your UI interactions. Without further ado, I'm sure you'll all be relatively familiar with this part, so I will just skim over it. This is a standard HTML page with no styling at all. It's ugly. HTML looks like this. It is purely a template for web page structure. It incorporates no styling at all. It's a markup language, so if you've ever used Markdown before, it's a similar idea. It structures a web page. So for example, here, you can see that we have the title, which is what appears on like the tab, a main header, which is an H1 tag, a subheader, which is H2, and then an unordered list containing list elements as individual bullet points. Moving on, CSS. Without a lack of a better word, it's making pages more pretty. I'm not saying that this is pretty, it's still pretty ugly, but it's a good example of very basic CSS just for those who haven't developed on the front end before. So you can see we've got color now, the main title is bold and centered, and we've lost the ugly bullet points from the list. So how have we done this? So as I've just mentioned, CSS describes how HTML elements should appear on a web page. It is a style sheet language, so neither HTML nor CSS are considered a programming language, and CSS is designed to be reusable across multiple elements. So for example, styling an H1 tag will style every H1 element across the page or however many pages you're applying your CSS to. On a similar vein, a single CSS file can be used to control the styles of many HTML web pages, and it can be written within a .html file, or it can be imported separately and be stored as a CSS file. So as a brief example, the main page heading, I've coloured dark blue, I've given it a big font, made it bold, aligned it in the center and given it a font family. And that creates the font that you see here. Again, not very pretty, but a simple example, you know, in reality, CSS is a lot of work. As you can see, the page doesn't look that great and there's quite a lot of information here. So, you know, I'll come on to that in a minute. Applying styles to elements, another key theme of HTML and CSS is the use of classes and IDs. So within a class or an ID, you can apply a single style to one or more elements with the same class, or you can apply a single style to a certain element using an ID. So an ID should be a unique identifier within HTML, and a class can be applied to one or more elements. So with this method, you could style, you could have separate headings and style them differently by giving them each a class or an ID, different class or ID. So as an example here, I've given the principals list an ID. You can't really see very well because of Zoom, but there is an ID there. And I've given it CSS here. So it'll be applied in the same way as just regular CSS using the template tag. So, as I've just mentioned, CSS is a lot of work. I really like this meme. So making a small change can completely mess up your website. The pros are that you can separate HTML content and styles, but on the other hand, and also you get greater flexibility. So you can define exactly what you want, how you want it. You just need to know how to do that. Equally, as mentioned earlier, you can reuse the same CSS across multiple pages. Unfortunately, as hopefully I've illustrated, okay, it is a lot of effort to make a page appear cohesive and particularly modern. The example I gave wasn't the most modern. Cross-browser compatibility, it can render differently in different browsers. It becomes quite complex to kind of manually create your styles, particularly within larger projects. And CSS is modifiable in browser, meaning that potentially a user could request, for example, a sensitive image directly from the browser, which obviously we don't want. There is also the dependency on an external CSS file.
Sorry, just did the phone.
Sorry.
That's my fault. Thank you.
This brings us on to UI frameworks. The example I've chosen is Bootstrap. I will come into a later slide why Bootstrap specifically. Bootstrap and some other UI frameworks, not all, incorporate a responsive design. So one of the main kind of flaws of raw CSS is that it doesn't handle out of the box scaling for you. So a mobile view is something that you would have to define yourself. Bootstrap is mobile first. It is based on Flexbox, which incorporates this responsive design. So we don't have to worry about how things scale. We just need to know how Bootstrap does that. Equally, all UI, well, frameworks, most UI frameworks have these built-in components. So for example, I'll show you in a minute, but buttons, cards, nav bars, the styling is consistent, which makes pages easily cohesive. It's customizable, so again, I'll come on to this later, but you can use CSS to tailor the appearance to exactly how you want it without having to do all the legwork. And the documentation is easily understandable, as well as there being an established community of developers. So chances are if you have a problem, you can find the answers on Stack Overflow. So Bootstrap took the page from this horrible, ugly thing to this slightly less horrible, ugly thing. But the key is that it was minimal effort for me, whereas the CSS before was quite clunky. So the next page, this looks like a lot. The majority of it is purely comments on how Bootstrap is utilized. So at the top there, we are importing Bootstrap via a CDN or content delivery network. And there are two main files, the first being CSS, the styles that we use from Bootstrap, and the second being JavaScript, which is used for things like animations on a web page. And you can see here, I won't pick on each individual item, but Bootstrap works via classes. So a bit like I described earlier with CSS and HTML, you give a class to an element and it'll be styled within CSS. So Bootstrap effectively handles that for you. For example, this list group item here indicates an individual bullet point and creates this nice kind of padding around the text, lines between each list item element, and just generally looks a lot cleaner and easier to read. Alternatives to Bootstrap, there are other styling frameworks, and I'm aware that Bootstrap is slightly out of date, but what it is established well. There are many questions and answers available online, a wide range of components, easy to use with comprehensive docs. As mentioned earlier, it handles the scaling and it's customizable, but hopefully you've seen now without the complexity. A note on page styling, you may have already kind of heard this from me, but it does not negate the need for CSS. You will definitely still need to understand vanilla CSS to get your web page looking exactly how you want. Not the best example, but even things like giving your body a background color. Simple example, but you're likely to come across it. So we have a style web page. Most pages that we use aren't static. We interact with them, for example, filling out forms, clicking buttons or links. And for this, we need JavaScript. I'm sure many of you will have used JavaScript before. It's known as the programming language of the web. It adds interactivity. There is no setup needed, no imports needed. It works out of the box on all browsers and is just generally considered an essential for modern websites. So let's say that we don't want to view the list text on our example by default. Instead, we want to click a button in order to view it. So the first thing we need to do is add a button. This is styled by Bootstrap, as you can see within the classes here. So button primary makes it that blue. Column 2 just sets the width of the button according to the size of the page. And then the auto margin centers it within its parent element horizontally. So we also need to give it a function when it's clicked. So we'll know what to do when that button is clicked. So in this case, we're calling a JavaScript function called toggle list, which doesn't exist yet. So we have the UI, that's great. How do we build interactivity? So by default, we want the list to be hidden because we want to click the button in order to view it. So the first thing we need to do is create a JavaScript file. In this case, we call it script.js. And we add this to the head part of HTML. So the head part of HTML is effectively like the metadata for the page. Any imports, the title to be displayed on the tab, things like that. And the body is the structure itself. So we add the script to the head. Equally, we create the toggle list function. The kind of theory is very easy. We're just checking to see if the element that we've gotten is currently being displayed. If it's not currently being displayed, we want to display it. Otherwise, we want to hide it. So this button is effectively a toggle. So you click it once, you'll see the list, and you'll click it again and the list will hide. It's a very basic example, but it's quite fundamental. So again, click the button, see the page. Next. As a side note, jQuery can be used to simplify the function that we just wrote massively. So the first thing we no longer have to do is get element by ID, which is quite a clunky syntax. Instead, we can specify the ID using hashtag, which is like the general way of grabbing an ID in JavaScript and referring to it in CSS. And jQuery has this lovely thing called toggle, which just toggles the visibility of the element. So that's quite a simple example. We're going to add another one. This time we're keeping a count of the number of times we've toggled the list. We'll come on to how to improve this in a minute. But we start with the HTML. We give an ID to the part that stores the count. We are modifying the JavaScript we've just written to have a global count variable and increment this every time that button is clicked and this function is fired. So we have the same horrible jargon that we wrote before in vanilla JavaScript, just checking that it's displayed or not and toggling it. But at the end here, we've added a text content to update the count. Again, you can simplify this with jQuery using this lovely text rather than getElement.text content. And you can see on the side there, it just increments the count. Very, very basic, but again, fundamental. The problem with this, we have to update the text manually, which becomes quite overwhelming by the time you have more complex applications. So the solution to this is a UI library. I've used both React and Vue, but I'm going to be talking about React today. So React is a way to, well, an easier way and a faster way to create dynamic and responsive websites. React, most importantly, is component-based, so it's separate and most importantly, reusable bits of HTML and JavaScript code. Being separate and having things separately, each file should do perform a very specific action. So you should be able to focus on making each individual component as robust as possible, which then promotes better development. It only updates the parts of the change, which makes it efficient. And as mentioned, it's a JavaScript library. As the name might suggest, it's the cooler version of vanilla JavaScript sites. So we usually use a build tool like Vite. One of the main reasons I like Vite specifically is it has hot reload, so I don't have to manually update every time I make a small change to the React code. I can make a change and see it instantly. It's written in JavaScript XML, which means that we write both HTML and HTML, JavaScript, and potentially CSS within a single JSX file. The first thing we have is an index page. Now the head is the same as what we've seen before, just importing styles for Bootstrap and our own style sheet. But what has changed is the body. So we're importing a new JSX file. So the next step is to look at this. This looks like a lot. In reality, it really isn't. So create root is exactly what it says on the tin. It creates a root so that you can display React components on a browser DOM node. In this case, the node is the root div that we saw earlier. Strict mode is a development feature to test components that lie within that tag. So in this case, UI demo, it's a good development tool that can spare you some problems with things like component lifecycle and helps ensure component reliability. The main thing though is UI demo. This is the React component containing all the functionality we've created so far, and I'll show you how it changes writing in React. There is a lot to unpack here. We're going to start with states. This syntax at the top here, don't know if you can see my mouse, looks complex. In reality, it's a getter and a setter. And just as we did before, by default, we don't want the list to be visible. So we're going to set the state to false, and toggling the count, we want that to, toggle count. We want to set that to 0 initially because the button hasn't been clicked yet. So we have a single function just as we did before, except rather than updating the HTML directly, we're updating these variables that we've just created using the setters. So again, set list visible is either true or false. It toggles whether the list is visible or not. Equally, the count is incremented. Very simple. But the HTML in the same file uses these variables directly. Conditionally rendering the list is basically saying that if list visible is true, then we want to render whatever is within the rounded bracket, which in our case is the list. And at the same time, we're simply displaying toggle count using that getter at the top there. So an overview of the whole file. This is a functional component that incorporates both JavaScript and then it returns HTML to be rendered. It was something that I found quite interesting when I first started using React, but it's quite a common theme now. But the biggest difference is that there's no longer any need to manually update HTML elements. That was a really small basic example for those who haven't seen anything like this before. So I'm going to give a more exciting one. So this is our Google Notebook management tool for those in CellGen, so that they could start and stop their own instances on the Google Cloud without having to ask our service department to do it for them. So as such, there are many notebooks belonging to many people, and we want to view them all. So each card is a separate React component. But not only is each card a separate React component for each notebook, but within each card we have separate components as well. For example, this instance icon can render maybe a lock. If the notebook is not being run, it renders a moon. And if it is being run, it renders a little play button. Instance title similarly is red or green. Instance text is displayed when a notebook is changing its state, so when it's being started or stopped, or if it's running, it will render a URL. The buttons are used to start and stop an instance, but there's a single overall notebook state held by the parent component, which propagates to each individual React component. And this would be something that's very complex to write using vanilla JavaScript, but actually the React has handled the bulk of the work, which means that I can focus on making it as scalable and maintainable as possible for future developers, which obviously is good practice. Generally speaking, when we're developing user interfaces, people talk about user experience, and I always find this very interesting concept. I thought this perfectly illustrates the point. Either ketchup bottle is a user interface, but who wants to be bashing the last bit of ketchup out, desperately trying to get it out when you've got a squeezy bottle that can handle that load for you? So I think, yeah, when we're developing interfaces, you need to consider user experience, because either works, but which one is better and which would you rather use? We're getting to the end now, I promise. Tips for UI development. Use a framework such as Bootstrap or Tailwind or Bulma or Chakra, whatever you prefer, to keep styles consistent and do the heavy lifting for you. Avoid using inline styles. It gets so messy and hard to maintain. Wherever possible, write it in a separate file, give IDs and classes. And styling can be a really fiddly job, so use the developer tools on your browser to help you. And if anyone wants any pointers on that, I'm happy to provide. State management, again, it should say library, it's not a framework. Use a library like React or Vue. This will do the heavy lifting for you and allow you to focus on the maintainability of your website. And just in general, the usual, keep code readable and separate where possible using components, and test it in different browsers and on different screen sizes. I quite like this slide because users always say that they want what they want, and then things change. So consider the client. But most importantly, don't be like this guy. React and Bootstrap are brilliant tools, but you need to understand the fundamentals first, and you will struggle without the basic CSS, HTML, and JavaScript knowledge. So I can appreciate that the examples are really simple. If you want to read fully commented code and try and play around with it, see what it does for yourself, I do have a repository set up. The slides are also on there, so please feel free to give it a try. Thank you. Thanks for listening to my rambling. Questions? So that's me off the hook.
So I don't know about React and everything. The code needs to be compiled before going to the browser. Can you just, the JavaScript, you can load JavaScript file and run it directly. Is it the same for React?
That's a good question. I haven't used React in a while.
You need a build
You need
tool,
to build.
yeah. So
React feet, yeah.
Yeah.
Feet does it, yeah.
Needs to be transpiled.
And that is transpiled, maybe it's converted to JavaScript, essentially.
It's like TypeScript, but it's not, it doesn't really need to be compiled to anything, it's just something translated into whatever you need. Some flavors of React will allow you to do web directly. It really depends if you start using the fun stuff like embedding HTML and JavaScript and CSS in the same files. But you can also write vanilla JavaScript directly in the browser. Vanilla React right in the browser.
Thank you.
you. Right, we'll go straight into Steve, who's hopefully runs on quite nicely from that. Who's going to be talking about how we test.
I will just say,
stuff.
I was at a conference for 4 days last week, so this would not be published as I might need your help for a minute for the technical stuff of that. Because I don't know how to get the presentation notes. So can you help me?
I think we're probably, if you join the Zoom,
Yeah.
then you get the opportunity to just share a window.
Okay, can I do it
No, hold on.
like that? But it won't show up here though, will it? I just try.
Will it?
You can't plug in here then directly.
Don't think you
Put in.
don't. Is it?
So I just try.
You've got desktop 1 and desktop 2.
Let's just try. Hey?
So it was that.
That.
in there.
Yeah. It's difficult because I can't seem to.
Your notes and slideshow are both browser based. Just move your tab to a different window and have one window on your laptop.
Right, so if I look at you. You what?
It said presentation. If you go on that drop down again, there's something that said new. I thought some of the split thing on Google is presentation display options. It says at the bottom. Maybe not.
Screen on this.
Yeah, so I've got full screen on this, haven't I? Yeah. Okay. Right, so if I just stop sharing for a minute. Right. I can't seem to get. Fortunately, I can't seem to get present to view. We'll get there. Right, I've got those here. Opening up in a new window.
So it's set up, they set up.
Hey. That's not sharing.
So
Yeah, so share this one. Okay, so now I've got
yeah, that's moving.
then. Yeah, okay, so I'll try my best here. It might be a bit tricky. So I'm going to talk to you today. Yeah, I'm going to talk to you today about how we test and build for maintainability and robustness. And this is been partly written by Sina Nair. She is actually online and she's going to come online a bit to sort of share some code. So this is a change from the original talk. And okay, so the talk today is a change to the advertised program and it's titled How We Test and Build for Maintainability and Robustness. So because we support a production lab, it is important that our applications are available all the time. Any downtime can halt sequencing, which has the potential to cost a lot of money and lose valuable samples. So today we're going to talk about how we test and build our applications using Traction as an example. We're not going to tell you how to do it, we're going to show you how we do it and why. We believe that our testing and building strategy has led to create an application that is easy to test, robust, with a low level of technical debt. The architecture is modular and clean, which means that developers like to work with it. And we're constantly assessing and improving, and we have regular sessions to review and reduce technical debt. So, what does Traction do? So Traction is a long read limbs, and it's able to support high throughput sequencing for PacBio and ONT. Traction supports a limited range of functionality. So it has a sample reception for importing samples from various sources, for example, SequenceScape. It does library creation. So it creates libraries from imported samples and adding metadata and tags. They can also do things like batch library creation, which can save a lot of manual work in the lab. We also do pooling, so we create pools from libraries or samples, and we add unique tags up to 384 plex. We also do run creation, which is creating runs from libraries and pools. We do sample sheet generation, so we support ONT and PacBio. So for example, for PacBio, we support the Revio and the SQL platforms for all currently supported versions. And we also do volume tracking, which gives accurate information about how much library has been used and how much is left. And this data is also pushed to the warehouse and can be used for things like top-up management. We also do location tracking, so where users can scan labware into locations when they're received or moved. And it can also be used to destroy labware and exhaust libraries. And Traction can display locations of samples, libraries, and pools. We also do barcode printing, so the users can print barcodes for libraries and pools. And Traction can also be used to print multiple barcodes for laboratory workflows. We also push data to the multi-limbs warehouse, so we push sample, run, volume tracking data to the warehouse for reporting and downstream analysis. So, a bit about the architecture. So Traction is actually split into a service and a UI. The service is generally responsible for creating and modifying data and pushing data to the warehouse for reporting and downstream analysis. The data model is actually quite simple and it has no dependencies on external applications and could potentially receive data from anywhere as long as it is in the correct format. And it has been built using the Ruby on Rails framework. The UI and the service are separated as most of the complexity is actually in the user interface. We found that using a monolith created high levels of technical debt, and we were creating persistence for things that were transient. And Ruby on Rails is not generally a good fit for rich user interfaces. So the UI is actually built using the front-end framework Vue.js. So we will talk a bit about Vue.js today. So it's also built in such a way that if one part goes down, then everything else will still work. For example, if the messaging system fails, a user can still process samples and the messages are queued or dead lettered and can be pushed later. The broker itself is configurable, so it could potentially push to any message queue anywhere. For example, if Sequencescape or Labware were unavailable, then the users would get a message, but nothing would fall over. And even if the service was down, the UI would still work, but it would actually be fairly useless. Each part is tested and deployed independently, and it is also built in such a way that bits can be swapped out. So, for example, samples could be ingested from elsewhere, or traction itself could be removed as long as any replacement can populate the warehouse. So let's talk about a little bit about the testing architecture and the CI. So we use agile development and a deployment pipeline, and I'll talk about what we're going to test, our test setup and our test workflow. But for this section, I will generally concentrate on the user interface only, as there wouldn't be enough time to explain how we test our whole stack. So for our agile development, there are two types of work. There's user-led and developer-led, which is generally technical debt. For the user-led, long read will come to us with a new requirement. If it's more complex, we would meet with them to identify requirements and agree acceptance criteria. We would then write a story, estimate how much work it will be, and select a priority. And this would then go to our product owner. Once approved by the product owner, it's prioritized in our weekly sessions and moves to our Kanban board. Once any work is complete, it will go through a standard agile workflow, code review, CI, UAT, and then we'll put it onto training, which uses production data, and we would finally release to production. On average, we generally release to production once a week. We also have a program of technical debt work. So, for example, dependency management, upgrading framework versions, and refactoring complex code. This goes through exactly the same process, but the stories are generally developer-led. So, what do we actually test? So we generally create unit tests for our components, our API, our stores, our state management, and our utilities. So for example, we've got services for our external dependencies. We also create end-to-end tests for our views and pages. We try not to repeat ourselves in our unit tests and end-to-end tests. And our end-to-end tests generally focus on the overall functionality, for example, creating a pack-bio run. So what is our test setup like? So for unit testing, we use vtest, which is a newer framework actually built on top of Vite, which, as Jessica's already explained, is a front-end build tool. It's actually got quite a similar syntax to Jess, which is probably the de facto tool, but it's far easier to maintain and is actually much faster. We currently have 1,500 unit tests, and in vtest they run in 26 seconds. So for our unit tests, we only mock things that we can't control. So for example, our store actions to retrieve data via the API. We've created our own factories, which have a standard response for an endpoint. And a particular factory will create a single source of data for any endpoint which is shared between our unit and our end-to-end tests. So we use Cypress for our end-to-end tests, and Cypress is a next generation front-end testing tool built for the modern web. So we have 68 tests for that, which run on the CI in about 4 minutes. And you can also run it locally, and it gives a good representation how the page behaves. And it's saved our bacon many times with difficult to find bugs. So, what is our test work like? So when we move a story to in progress, there's no demand on our developers to test in a particular way. Some developers do TDD, others write code first. We make sure our unit tests cover behavior and not implementation. And part of our code reviews now will be to look at the tests and ensure they make sense. However, the workflow is generally the same. So we'll create tests locally, ensure our unit tests pass before pushing. Sometimes we only run end-to-end tests on the CI. And generally, we would only have 1 to 2 end-to-end tests, a happy and a sad path for any feature. We also have GitHub Actions set up to run CI, including unit tests, end-to-end tests, formatting and linting. So we also review documentation, so we would expect each new feature to have sufficient documentation to explain the code. And on release creation, this is actually published automatically to a GitHub page. So now I'm going to give you some real world examples of how we build and test stuff and why we do it this way. Firstly, I'm going to talk about a crucial functional requirement, smart link versioning. And I will also explain how we implemented a non-functional technical debt project where we moved from a HTTP library called Axios to use native fetch, and why we did it and how we added value. So one thing to note is we all test, hopefully, but we shouldn't do it just because we have to. And we need to be self-critical about why we are doing it and how it actually adds value. So for the functional, I'm going to talk about smart link versioning. So for those of you who know, smart link is a set of PacBio software tools for SQL 2, 2E and Revio systems designed to set up and monitor long read hi-fi sequencing runs, review performance metrics, analyze, visualize and annotate sequencing data. So smart link is installed as a server instance. Users upload a sample sheet which relates to a particular run of samples to this instance, and they will then start a run using this information on a sequencing machine. So when we first released Traction, we were on SmartLink 9. One day, Craig Corton, who's in the long read team, rocked up at my desk when we were still working in the Ogilvy and told me that MPG had upgraded the SmartLink server to version 10 and the sample sheets Traction was created. No longer worked. So what did we do? Well, thankfully, those were the days when we were doing a run a week, sometimes with a single sample. And Craig was modifying the sample sheets manually whilst we dealt with the issue. So there were a variety of constraints. So long read needed to be able to use older versions of SmartLink. The server upgrade was irreversible, and there are only 2 server instances. And the SmartLink upgrades generally involve breaking changes and are not backwards compatible. And also creating sample sheets is tricky and involves collating data from a variety of sources. So the solution was that we created SmartLink versioning, which was configurable. And hopefully Sina will be able to show you a bit of the code in a bit. And it allowed us to support multiple versions at the same time, which allows them to move across to newer versions. And also we have a test SmartLink server instances allowing testing workloads. So how do we create a new SmartLink version? So the first thing that happens is we will get a technical expert from long read to analyze and let us know the changes. And then we update the configuration, add the new SmartLink version and add some tests. Each SmartLink version can be activated or deactivated via a database flag. And when we deploy to UAT, we will create test sample sheets and ensure that they can be uploaded to the test instance. And then finally, we would release to production. And this would be done ahead of updating the production instance of the SmartLink server. So I'm going to try now to pass you over to Sina, who's hopefully here and is going to walk you through some code.
Thanks, Dave. I will try to share my screen. Hopefully it will work. Okay.
It might also be worth Sina showing them some Traction run because I didn't get a chance because of my setup here.
Yeah. I hope you all can hear me and see my screen. Can you? Yeah. Okay. So thanks, Dave. I'll give a walk through the code, and in this walkthrough, we will explore key files that contribute to the SmartLink feature, and in the Traction service and Traction UI repos. We will cover configuration files, validation logic, models, and the UI component state management, and end-to-end testing finally, to understand how the system ensures compatibility with PacBio's different SmartLink versions. So to begin with, this is the configuration file that defines different versions of PacBio SmartLink software and their respective parameters. This ML file enables the service to adapt its operations based on the specific SmartLink version in use, ensuring compatibility and proper functionality. So as you can see, there are like certain flags, active and default, and the active specifies which all SmartLink versions are currently active, and the default is as it specifies, which is the default one. And moving down, we can see different attributes associated with the different versions. Some of them are specific to certain versions like this, and some of them are shared across different versions. And then the next bit is about, sorry, I think this is the, okay. So the next is another configuration file, which is a packbio.ml file. And this configuration file defines the configuration for processing PacBio sequencing data, including parameters for sample sheet generation. And this configuration ensures compatibility with PacBio SmartLink software, which also ensures that the data works smoothly with PacBio SmartLink software. So this is something we create a sample sheet out of a specific SmartLink version where we are specifying which columns need to be generated. And the next bit is about a validator. This validation class validates the SmartLink options, which ensures that it is complying with the version specific validation rule. And this again helps maintaining data integrity and compatibility within the service application. Now I'll move on to the model layer. This is a PacBio run well model. And as you can see here, it uses this validator class that I have mentioned before for the validation. So it actually basically validates all the fields associated with that particular well, which is connected to a particular PacBio SmartLink version. And then the next part is I'll move on to the UI. This is the UI part. And this is the place where we define which options are used in a run well. This configuration specifies various parameters that users can select or input when setting up or reviewing PacBio sequencing run. You can see the different parameters associated with it. And this is a view component which uses the previous configuration I was talking about. And this set default values for wells in PacBio sequencing run. Using this configuration, this component is responsible for dynamically generating input fields corresponding to the current SmartLink version's well options. This enables users to efficiently apply consistent default settings across multiple wells. And then this is a PacBio run show. This is to facilitate run visualization. And this view component presents detailed information about a specific PacBio sequencing run. This component fetches the runs associated for all the renders data related to a selected run. And it also provides users with an interface to view and interact with run-specific details within the application. Now comes the state management part. This is a store. If you go up, like we can see, there is a store creation. It defines a PacBio run create store. And this manages the creation and the state of PacBio sequencing run, ensuring a centralized approach that separates UI components from the state management. And we can see there are like specific methods, actions like responsible for the run creation process, such as initializing values and validating inputs. And also there is something to fetch all SmartLink versions. So it maintains a clean separation between the UI and the underlying store logic. Finally, we will go through the Cypress end-to-end test, which validate the entire process, ensuring that the UI and the backend logic function correctly under different SmartLink versions. So this contains test for creating PacBio sequencing run. It tests the application behavior against different SmartLink version, ensuring that correct options and validations are applied based on the selected version. So as I'll probably show a specific, so you can see there is something to test for V12 review. And if you go down, like there will be V13. So there will be one whole set of test cases for each of these smart link options that we are currently using. And I know this is a very quick code walkthrough, but the time is limited. So this concludes the walkthrough where we have explained the most important aspects of the code required for the smart link feature. Now I will hand it back to Steve. Thank you.
Thank you, Sina.
Please stop sharing.
Okay, so for the next bit, I'm just going to talk about how we address technical debt. And so generally we will ask ourselves a list of questions before we start anything. So if we have an external dependency that is not well maintained or does not work well, it's generally a good candidate for change. And we also like to work on things that improve collaboration and teamwork and help developer productivity. So we generally try not to change things just for the sake of it. For example, choosing the shiny new tool. So as an example, I'm going to talk about how we moved from a popular library called Axios to use native fetch. So we have a centralized API in our application with a request and response, and it was originally built on Axios. And we decided that we wanted to remove this in favor of fetch. So what we did was we followed a strategy that's created at the beginning to ensure that it had no impact on other work, could be done incrementally with no impact on users. So the first thing we did was we created a V2 API, which was namespaced. We then created a new request and response with tests. But in this particular instance, we actually did use TDD. So we then namespaced our existing API into the V1 namespace and copied all of the code into that namespace and updated our import statements. So we then created a test factory framework. So we created a base factory which could support Axios or fetch. We then created user stories for identifying all of the endpoints that needed to be moved with a story for each. We then moved each endpoint to V2. We did this work individually, so each developer worked on it, but we did it in parallel. So we would create a factory which used that base factory and used data from a fixture. So we would move tests so you actually use the factory with Axios, and Sina will show you how this works in the code review later. So we then moved the endpoint to use the V2 API, which would break the tests. And our final stage would be to fix our tests and ensure the endpoint is still working. We would also remove low or no value tests, some of which were testing implementation and sometimes actually nothing. We then removed the V1 API, removed all the references and transferred any code which was still using V1. We finally removed the V2 namespace, and then the last thing we did was remove Axios as a dependency. So we would be merging and deploying after each story. We'd deploy from branch and then we'd merge into the main branch. This actually took nearly a year, and we were generally pairing for about 90 minutes a week. And in the pairing or mobbing session, everyone had a go at leading. We also added more complete documentation and moved to more standard JavaScript. We never actually had to change any of our end-to-end tests apart from using the test factories, and they were a great way of finding bugs. So over the whole year of this work, we found 2 minor bugs, but we ended up removing 15 to 20,000 lines of code, mostly from test fixtures. The question is, how did this actually add value? So it reduced complexity. It made it far easier to maintain. For example, we recently had a bug where a user was trying to delete a library and it gave him a strange error message and said it didn't delete, even though it did. We found that this was a bug in how we implemented fetch, and it was a one-line change with 1 new test. We also removed the use of an external dependency, and we had a lot of good knowledge sharing, teamwork and collaboration, with a better understanding of our code base and standardization of request, response and async. And we also now have a single source for our test data. So I'm going to pass you back over to Sina again, who's actually going to walk you through some of the code.
Hi, I'll share my screen again. Okay. Thanks again, Steve. In this section, we will walk through the key parts of our Axios to fetch migration. We will start by looking at how requests are created and handled, followed by response management, API configuration, and integration into the store. Finally, we will review the specific implementations of it. So we begin with a create request file, which encapsulates all the standard HTTP methods such as get, post, put, and delete. This abstraction actually allows us to build API requests with minimal duplication and provides a consistent way to construct query parameters. And create requests, to ensure the reliability, we have a test file, unit test file for this create request. And as you can see, there are like describe blocks, which will relate to either a function or a groupable behavior. All tests are sensibly named, so they are easy to understand. And the tests are created in such a way that the body is clear and readable. We minimize the expectations in each test. As you can see, like there is only one expectation being set against each of the test cases. And the test file is well encapsulated. The only thing we are mocking is global fetch. Now, moving on to the next important bit, the response helper. This plays a crucial role in handling API responses. And this handle response method is actually where all the heavy lifting is done. And we gained a good understanding of how fetch works along with all of their handling. We also create an object, a new response object, which encapsulates the behavior of a response. And again, how to verify how we tested it, the response handling. It provides unit test for each of these methods. And again, this is encapsulated. The data we use to test this is in the test itself. So that's actually making it very simple and transparent. The tests again are appropriately named. And this is where we test the different type of errors that we are expected for different error condition. We create a standard mock response, which mimics fetch, so there is no need to create a request. We create tests to mimic success and failure responses. We use promise.resolve to mimic async behavior. Now, how we build it? Like this is the config file. This is a single centralized file where all the endpoints that we are used in our application are listed. And this modular approach simplifies endpoint management and ensures maintainability. And how it is being built is there's an API builder class, and based on our configuration file that I showed just before, this API builder constructs and executes API requests dynamically based on defined endpoint. This build requests for all of the endpoint which are executed when the user creates the request data. And this is our index file for all the stores. When the application loads, we initialize or build the API as a whole inside the store. This setup, which we can see here in the highlighted part, ensures that the API calls are available throughout the application. Now I will move on to a typical example of how a particular functionality has been moved from Axios to fetch. This is printing, which is quite an isolated one. And there is a print store. As you can see here, I'll go to app. This defines a store called store for printing. And this printing store does what it says on the tin and is responsible for creating and sending print jobs. It will also fetch a list of all printers available. Moving on to the printing unit test. So as I mentioned, to validate the printing functionality, this includes unit tests that use a factory to mock the printer data. Here you can see we are using printer factory across all models, and it's been created at the top. And the factory is used to mimic the printers that are received from the service. We will test successful and failed responses by mocking the underlying get or post request. And there is a describe block for each of the actions that we are expecting. There is one for fetch printers and a success path and a failure path. And so we create one describe block for each of these methods. Then how the printer factory looks like. The printer factory contains a standard set of data that mimics real printer data from the service. It is built on top of a base factory and includes method to return a store specific data as well. So it's mimicking the store data as well. And finally, moving on to the base factory, it is a very simple JavaScript file and returns content based on some passed in data. This allows you to create axios of fetch response, and it is flexible enough that other types of responses could be added. So this is the final part. I will now pass it on to Steve again to continue the presentation. Thank you. Stop sharing.
Okay. So hopefully this is the final slide, part one. So I just wanted to sort of share some of our learnings from this and what worked for us. So we found that our modularization and separation of concerns wherever possible, breaking things down into independent blocks, reduces complexity and made it easier for us to test and work on things in parallel. Effective testing was a really good thing for us, but so using robust and up-to-date frameworks, making your tests readable, test behavior rather than implementation, make sure you code review tests, don't repeat it across tests, and we've moved to use factories over fixtures, only mocking things that we can control, and a really good learning is if your tests are quite complex, that is probably a code smell. And we'd also like to say that tests should be performant and complete quickly wherever possible to enable rapid feedback loops. We try to be agile. So we use Kanban. It really does help us, allows us to take more time and improves the quality of our work. And it also allows us to make technical debt part of our backlog. And we actually have a weekly technical debt stand-up. So we also use retrospectives to work through our problems and decide on solutions. And this is a really important one. Agile should be agile. So be flexible with your processes and don't tie yourself to particular frameworks or artifacts which don't actually work. We try to release early and often. So if it's ready, release it. It provides quicker feedback from users. It's much harder to find bugs in big releases. And we generally release from branch when things are volatile, so you don't need to back out. And we also separate our feature-led and our dependency-led releases. Collaborate as much as possible. So we like to build relationships with our customers, our stakeholders, meeting regularly. We pair, we mob, we mentor, we coach. We like to empower people. So we use research stories and mock-ups, and we have regular knowledge sharing, problem solving sessions. And we also have post stand-up sessions for deeper dives into current work. Graceful error recovery is a really important one for us. So error messages should make sense to users. And this is something we're still working on. We like to use exception notifiers, and processing samples should not stop for downstream errors. So for example, sending a message to the warehouse fails, it shouldn't affect users. And also external application dependencies should also fail gracefully and not impact users. Effective monitoring and logging, and this is something we're actually still working on, and it's quite an advantageous to us being part of IDS. And we're introducing Nagios to give us a better oversight as we were having issues when our message queues were falling over. Effective dependency management, so depth-food, dependable technical debt boards, and keep your dependencies up to date as possible. And I know that's hard. So we do manage our technical debt, and we have a rolling program of work. If you don't keep on top of it, it gets out of hand. And it also brings together developers together and improves productivity and performance. We try to minimize our external dependencies, only use ones that are necessary. So large amounts of external dependencies can increase maintenance costs. And if you do use them, make sure they're actively maintained. So for example, Bootstrap, which is one that we did use, but we actually removed it couple of years ago, and it was starting to cause us all sorts of problems when we were updating to Vue 3, and it was also quite hard to change. We found a lot of the usage was actually quite opaque. So we removed Bootstrap and actually created our own UI components and introduced Tailwind. And we now have our own component library in conjunction with Tailwind, which is actually quite low maintenance. And thanks to Sina for building that component library. And finally, our deployment process is mostly automated using Ansible and Terraform. So it's fairly easy to roll back. We have a deployment project with a repo that's shared across the team and across applications. So we can now deploy in seconds. And that's it. So thank you very much.
Any questions for Steve? Sina?
Why Vue or React? Why Vue over React?
So I think it was my decision that I made about 6 or 7 years ago, having a look at Vue versus React. I find Vue a lot easier to work with. I know a lot of people prefer JSX, but I actually quite like Vue because it has, you've got a template, you've got a script, and you've got your CSS, which works really well. And I really quite like the community and the way that community is going. So in fact, last week I was actually at a Vue.js conference in Amsterdam for 2 days. And the stuff that they are doing is amazing. But even one of the questions that was asked at that conference was, how do you convince someone that using React to move to Vue? And the answer was, don't. You don't need to. You choose the tool which is best for you.
Where do you deploy?
Sorry?
Where do you deploy?
To?
Yeah.
Yeah, we deploy to OpenStack, yeah.
For your end-to-end tests, is that I didn't quite understand. Is that using mocked data? What do you run on? Because as far as I understand it, the tests sort of run as a sort of outside your code base, don't they?
Mm-hmm.
Are you running on a deployed version, or is it mock?
So we run it on CI. So the factories that Sina showed you, we use them. So we plug. It's a bit of work that I did a few months ago, which is really cool because Cypress has got a fixtures folder. And what we were finding was that our unit tests and our end-to-end tests had to have different fixtures, but they were exactly the same. So we had thousands of lines of code, which in the end, the unit tests were using the same data. So what we did was we created these factories so you can actually load the factories asynchronously into Cypress, and Cypress has got something called intercept. So it will intercept the request. The request actually has to have exactly the same URL, but then you can plug the data in. So it's exactly the same as what would happen if you had a proper request and response.
So it's intercepting the
It
request
intercepts
from the application.
Yes. So when Cypress makes a call, so for example, if it does visit page, underneath the hood, that will be a request, which will make a call to usually our service.
Yeah.
So we'll intercept that request and replace it with the standard response. So that can be a successful or a failure response.
Cool.
But I mean, you know, if you want to see any more, if you want to me to show you any more, I'm more than willing to. I think just today, because of what I had last week, to try and do a live coding deep dive would have been quite difficult. But I definitely I was at the Vue.js conference last week, and I definitely got imposter syndrome because there was somebody up there in front of 1,000 people building a user interface in Nuxt and WebSockets in front of my face. So yeah, I can't do it.
How? Oh, sorry, go on.
So it's Cypress, the Cypress tests, is it like testing the ability to like click on things on a web page, or is it testing like functionality that
So it's purely browser based. So it's totally independent of your code underneath. That's why it's really good for finding actually bugs in your code. So like I say, when we did the technical debt work, when we moved from Axios to Fetch, we never changed a single end-to-end test apart from actually the data that was being returned. And that's really important for end-to-end tests.
It lets you kind of define the user clicks here and the user clicks here. How does it?
Yeah, that's pretty much, it says click this, do that. That's pretty much how it works. It's fairly standard. So it will look for, you can do it by IDs or we've started using data attributes, which are a lot more because they're separated from the styling.
And does it let you test like that things look how they're supposed to look? Like, is there a visual component to this is the right color and
No, I mean that's what humans are for. It really needs to be humans testing that stuff, and that can be quite tricky. So, for example, we've just updated to Tailwind 4, so there's a lot of stuff that can be done by tests because the tags and stuff will change, but it's just by mostly looking at it, we'll do that kind of thing.
And also, I think we can test classes, but we don't usually go into that level of detail. Our end-to-end tests are mainly focusing on the main pages and to test the overall functionality. And we do it in a much more detailed level in unit test, and we try not to repeat across unit and end-to-end test. Otherwise, it will be like quite a lot.
Interestingly, now VTest now has a module for testing accessibility, which is quite interesting.
Hi, Tom. I can see you have raised your hand.
Hi. Yes, thank you both for your talk. It was interesting to hear you do weekly or weekly-ish deployments. We say in my team we don't quite manage weekly deployments, and so I'd be interested to know, like, how do you make that possible? Like, what's your branching strategy? Is your front end and back end always independently deployable, or do you sometimes have to like release in synchrony? And like, how many developers as well are you working with together?
So we've got 12 developers on our team. So only 2 of them work on this. So we've got 2 FTE working on this project. If anybody knows anything about our team, we've got 80 different repositories and 23 production applications. So there's a lot to unpack there. For our branching strategy, it will generally be based on the story. So each feature will have a separate branch. We will sometimes deploy from branch if it's volatile to test things. Yes, the UI and the service are independently deployable, and we will generally deploy them independently. Sometimes there's stuff that the UI needs from the back end, so we might actually deploy the back end first, but we try our best to make sure that we can deploy them independently and that they're still working. And we've tried sort of a bit of feature flagging as well, which is quite tricky sometimes. Is that all of your questions answered?
Yeah, that's great. Thanks very much.
That answered my question.
Did it? Good, right.
Right. Let's give Steve another thank you. Have we done a thank you? I can't remember. Thank you, Steve and Sina. We can go. If you're able to stay, we can say goodbye to people on Zoom because you're on Zoom, you can't join us for a drink. So next time. Actually, before we go, we have the next full stack community. Oh, I can't remember the day. I think it's the 19th of May, sometime in May. They're all advertised on the Software Developers Slack channel and on the Buyer Dev Network website, I believe. So look out for that. If you're able to stop for a drink, we all need to go and do it in a single transaction at the diner. And whoever's first, go and reserve a big table and kick people off. And don't kick people off.
Thank
you. So you can have drinks and things, not sandwiches and cakes. And
Very
everything. I don't think
much.
IDS run to that, but,
Speak to you later.
thanks everyone.
Boarding.